So what I want to talk about is the relationship between the view matrix and the modeling matrix. So we first started with modeling matrices, and we could do things like translate our teapot over by 3 units. And we can see that the teapot's moved over in the view. Most recently, we've talked about a viewing and using the look at command to change the camera. So suppose we move the camera over. Oh, I've gone the wrong way. Okay, let's move the camera over by 3 units. And now we're back to the same picture, right? We're looking at the same thing. So what's going on with the actual matrices? So our modeling matrix, the one that we stick in the uniform variable that we're going to pass to GLSL called the model matrix, this is per object, and it puts the object in the right place. We have a 3 over here in the translation components. And our viewing matrix, so there's only one of these, and it's going to be used for the entire scene. We also have a 3 here. And we see that when we multiply these two matrices together, we get something that's almost identity matrix. Now this -10 here is because our camera is sitting away from the origin. So if I go stick the camera back on the origin, of course we don't see the teapot anymore because I've moved it around, but now we get back to this identity matrix. Okay, let me reset these two cameras. We can see the same thing happens with rotation. If I rotate my object by some number of degrees, and then I rotate my camera by some number of degrees, which is approximately the same, and what we see is we get almost this identity matrix back again when we multiply the two together. So there's a duality here. I can cause a change in my scene either by moving the camera or by moving the model matrix. But notice, what do I see in the end? It looks just like it did in the original. I have a rotated camera, I have a rotated object, it looks like the same thing. If I reset these two things, it still looks like the same thing. In old OpenGL, there used to be something called the ModelView Matrix. These two things were multiplied together and stored together as this ModelView Matrix. In your code, passing to the GLSL buffers, I think it's most clear what's going on if we actually pass 3 matrices. So we're going to pass a model matrix, which has to do with our modeling transforms, as you did when you made your blocky animal assignment. We're going to have a view matrix, which is the one that comes from the look at, and there's going to be a third matrix called the projection matrix. When we talk about orthographic and perspective projections, that one will be coming.